In 2000, Dr. Stephen Stahl published what many of us consider to be the definitive text of psychopharmacology. The wait for the third edition is finally over. What has happened in the last 8 years? You're listening to ReachMD, XM 157, the channel for medical professionals. Welcome to the Clinicians Roundtable. I'm Dr. Leslie Lundt, your host, and with me today is Dr. Stephen Stahl. Dr. Stahl is adjunct professor of psychiatry at the University of California in San Diego. He's an internationally recognized clinician, researcher, and teacher in psychopharmacology, and is the author of more than 350 articles and chapters. His latest book is the third edition of Stahl's Essential Psychopharmacology. Welcome to ReachMD, Dr. Stahl.
Well, hi, Leslie. Glad to be here.
Now, Dr. Stahl, the question everybody's dying to know is why so long between the second and third editions of your book?
I wish I had a good answer to that. Correct answer is I wrote another book in the middle and had a lot of other things to do.
I think a lot has changed in psychopharmacology in this time frame. Tell us some of the highlights of what's happened in the last 8 years.
Well, it's led to a book that went from 100,000 words to 200,000 words and from 500 pictures to 1,200. So lots have happened. I guess you could put them into different categories. One would be understandings about diseases, and the other, of course, are a bunch of new drugs.
Now, also, technology has changed quite a bit in the last decade. How has that changed the way you teach?
The technology that's most relevant to psychopharm that has changed would be neuroimaging and genetics. Now, those aren't quite ready for prime time in the sense that they haven't quite filtered into practice with reimbursable kinds of tests that you can get, but I believe that's imminent. And in the meantime, what's happened is it's changed the strategies that people are already choosing drugs by.
Now, you spend a great deal of your time teaching both psychiatrists and non-psychiatrists about psychopharmacology. What do you find are the most difficult concepts for docs to grasp?
Probably it would be the mechanism of action of drugs or the mechanism of diseases that affect the nervous system. One of the problems is that I got a bad secret to tell you, Leslie.
Uh-oh.
We probably don't know how these drugs work or how the diseases work, but we have good stories and we've got believable, plausible hypotheses. With all the seriousness, though, I think that we know how drugs act on certain receptors, but we really don't necessarily know how that leads to therapeutic actions. And, of course, it's playing upon a brain substrate that we have even perhaps less idea about. I think we actually know how drugs work better than we know how the diseases work. So those are difficult concepts to grasp, partly because I believe the knowledge base of them can be thin or speculative or at least hypothetical.
Now, one of the things that I see physicians struggling with is the concept of receptor up and down regulation. Can you fill us in on what that really means, please?
Sure. Obviously, receptors are the number one things that drugs target. Some target enzymes. Some target types of receptors that are transporters. Really, it's still a receptor. And what happens is that a drug will basically bind to one of these receptors, and the first thing that happens in the here and now is an immediate change in that receptor's action, either blocking it or facilitating it or stimulating it. That's not the end of the story, though. That signal is received by the cell that a drug is playing on my receptor, and the cell reacts to that. And the adaptation can up and down regulate receptors. What that means is that the receptor on the cell tells the headquarters of the cell, hey, something's happening here, and the cell headquarters reacts by changing gene expression. And one of the things that it commonly changes is the number of receptors of the very thing that the drug is sticking to, either making more of them, that's upregulation, or fewer of them, making it downregulation.
And why should our listeners care?
Because it probably explains how the drugs work. How many of our drug actions are immediate? Probably only side effects. Maybe benzodiazepines and sleeping pills work. Most drugs work with a delay. And in fact, most side effects go away with a delay. And so it's thought that the time course of the cell's reaction to the drug to modify the number of receptors that it's making, and perhaps a whole bunch of other things as well, is the time course of therapeutic response and the time course of loss of side effects. One good example would be if you have, let's say, a problem in your stomach, nausea, or diarrhea from an SSRI. That happens immediately because serotonin goes up. But if your gut wall takes away the number of serotonin receptors there, then you don't have the side effect anymore. The downregulation of the receptors makes the side effect go away. And so we think that other receptors, different than the side effect receptors, are the ones that downregulate in order to get a therapeutic effect. So that all put together with other changes in genes with a delay is how the drugs really work, because most of them don't have immediate actions.
If you're just joining us, you're listening to the Clinicians Roundtable on ReachMD XM 157, the channel for medical professionals. I'm Dr. Leslie Lundt, your host, and with me today is Dr. Steven Stahl. We are discussing what's new and possibly even exciting in psychopharmacology. Dr. Stahl, a lot of work, as you mentioned, has been done in psychiatric genetics in the last few years. Can you bring us up to date on that?
Certainly. It appears that there are no single genes for any psychiatric disorder. It appears that there are no single genes for any psychiatric symptom. Genes don't seem to code for psychiatric disorders or for psychiatric symptoms. Genes code for proteins. Proteins that are in circuits can control the efficiency of information processing in that circuit. So if you've got a subtle molecular abnormality that's genetically derived and it changes the efficiency of information processing in a certain circuit, then it will not give you a mental illness, but it will bias you towards a mental illness. So it appears that psychiatric genetics is telling us that you don't inherit a mental illness, you inherit a risk for a mental illness. And that risk is not apparently robust enough with one gene to give it to you. It appears that what happens is a conspiracy. Many different genes have to conspire, maybe dozens of them. Or maybe there's a whole, cupboard full of 60 genes of which any dozen being abnormal working together could sort of diabolically create a mental illness. And even sometimes the gene conspiracy of several different genes is not enough. It's those genes in a stressful environment that reaches the tipping point. So modern psychiatric genetics tells us that you inherit risk or bias towards a mental illness, that if you have sufficient numbers of genes that are all abnormal, that they will possibly on their own almost reach a tipping point, but certainly in a stressful environment that will do it.
How about on the treatment side? Does psychiatric genetics help us at all yet in choosing which medication to use for which patient?
Great question, and that's the field of emerging pharmacogenomics. I suppose the right answer is not yet. There are a couple examples from cancer chemotherapy where genomics actually will tell you what drug to use or what drug to avoid. Psychiatry has lots of candidates, none of which have been firmly established. There is some very important work going on that is close to that, but I think it hasn't all been replicated. We're hopeful, of course, that not only will genes tell us whether you're going to respond to a drug, but also whether you'll have one of the side effects of a drug that might otherwise be avoided. So I think that that's on the horizon, probably very shortly, but it's still in the research phases now.
At the APA this spring, there was some buzz about a new antipsychotic called iloperidone, and they're starting to talk about pharmacogenetics with the use of this medicine. Can you fill us in on that?
Right, that's an exciting story. There are a number of ways to look at that. One is a specific gene called CNTF, or ciliary neurotrophic factor, has been linked to whether somebody gets a response to iloperidone or not. And there are 6 other genes which just have funny little numbers to their names that don't even necessarily have well-characterized functions that seem to correlate with the response to iloperidone. In other words, if you have the right form of 6 of these genes, you have something like an 80% chance of responding, whereas if you have only the right form of 1 or 0 of these genes, you might only have a 20% chance of responding. There's another drug, an antidepressant, which has not published the specific genes that they say are linked, called vilazodone, and it's supposed to be an antidepressant with serotonin reuptake and some serotonin 2 or serotonin 1A properties, and that is claiming that. All of these are early days, and the STAR-D studies even tried to look at a number of candidate genes to tell whether common, well-known antidepressants like citalopram will have specific genes that tell you whether you're going to get better on it or not. Again, early days, exciting. but not quite ready to be used on a daily basis.
Now, how does psychotherapy fit in with all that we've learned about psychopharmacology?
Better than ever. I think that psychotherapy can be thought of as a form of learning. Learning requires molecular changes in brain circuits. And one of the things that we're finding out is that you can facilitate the learning with certain drugs as well as with therapy. And sometimes 1 + 1 = 3. One of the most interesting ideas is the idea of D-cycloserine, which is a different form of an amino acid serine, and it stimulates NMDA receptors, the so-called N-methyl-D-aspartate glutamate receptors. When those glutamate receptors are stimulated and activated, they can cause synaptogenesis, long-term potentiation, and ways to put memory into a circuit. And if that memory is a memory or an insight or even a behavioral therapy to stop being afraid of something, then it's psychotherapy. And it turns out that if you give D-cycloserine to people undergoing behavioral therapy for OCD or for various types of phobias, you can, in some circumstances, enhance the chances of the success of the therapy. So I believe we're getting to the point where we may actually merge more and more psychotherapy with psychopharmacology.
Is D-cycloserine available?
I believe it is. It's an anti-tuberculous drug. It's not necessarily known how to use it or how to dose it. There's some questions about whether you should stop it after early treatment, or otherwise the effect will go away. And, of course, this is a wildly off-label use for it. But, yeah, I believe it's available.
Wow. Well, maybe it might help me memorize and get ready for the next set of boards, huh?
Yeah. Well, don't we all need it?
We sure do. Well, thanks so much for being on the show today.
My pleasure. It's been a lot of fun.
We've been speaking with Dr. Stephen Stahl, who's just finished and published the 3rd edition of Stahl's Essential Psychopharmacology. And what we say in our office is, if it doesn't make you smarter, it definitely will make you stronger. I'm Dr. Leslie Lundt. You've been listening to the Clinicians Roundtable on ReachMD XM 157, the channel for medical professionals. To listen to our on-demand library, visit us at reachmd.com. Register with the promo code RADIO, and you'll receive 6 months of free streaming for your home or office. If you have questions or comments or suggestions, give us a ring at 888-MD-XM-157. Thank you for listening.
Hello, this is Dr. Sharon Langsher with CarePages.com, and you are listening to ReachMD XM 157, the channel for medical professionals.